Actually, there's something which I keep notes. I need to send you notes. I've been forgetting that for a long time now. So let me
Yeah.
not put that off. Which notes are left over for me to send you?
So
This
the
alcohol
last one, I
thing.
think, yeah, alcohol thing.
Okay, यहाँ से send करना है क्या?
Sir, a few classes back, you told that LiLH4 will not reduce carboxylic acid, right?
LiLH4 will react with carboxylic acid as acid base. Acid base reaction करेगा, not react
Yeah,
in that.
but yes, but like, what would it form?
Salt.
Sir, but
H
like, I
minus
checked
will
that.
react. What is the salt here? H minus will react with H plus means what will it form? Hydrogen gas.
Yeah, no, what will be the final product? Like, I just want to make sure.
RCO minus La plus. RCO minus thrice Al3 plus.
Sir, I checked everywhere, but then it says it's gonna oxidize between.
What?
It says the LiLH4 will oxidize carboxylic acid.
Oxidize the carboxylic acid?
So reduce. I'm sorry. Sir, I checked the Essence Annual book also. There also it's.
I'm not so sure. That doesn't seem realistic here. Carboxylic acid, LiLH4.
Even Ester.
We'll go by acid-base reaction. I'll confirm. I'll check up. I'm now a little surprised, but it has been enough time that I've been out of the market that I should check it up at least once. So I'll confirm this. Carboxylic acids with LiLH4 is a question here, right?
I checked that book you told me, that Essence Annual book. There also it told that
Essence
it will.
Sanyal is not a trustworthy book for information
Oh,
at this type of stage. But what have they given? I am curious.
so I checked a few days back. But 1 second, let me
No, what have they given? I'm curious because they are generally
yeah,
not really wrong. Usually they are relatively accurate, I would say.
yeah, I'm opening it. Just a second.
So their data might be correct as well. So what have they given as the product there?
1 second. They didn't. I think they didn't directly explicitly give it. But 1 second. If I remember correctly. Mhm. Oh, yeah. I think you're right, sir.
No, what have they given?
Yeah, they gave that thing only. Remember
They gave what?
the H2 gas, Al H3 minus Li plus. So last time I checked, I said, wait, what? Wait 1 minute. Okay, then my bad. Hmm.
No, we can check again. It is not really that much of an issue.
Sir, but then like it's given like that thing's given, and plus it's also given reduction product will give RCH2OH as well. Yeah.
Yeah, that
Uh,
is realistically possible if you end up doing like with no water. I don't know how to explain it. It is feasible. That is why I'm also not 100% sure. That is why I wanted you to confirm from this book over here. What have they given here as of now?
I'll send a screenshot 1 second.
Yeah, send a screenshot, please. We'll start off with the doubts. Send me the. I think you already started sending. Let me just check out.
I didn't send
No,
anything. It's
send me any.
I sent you what's written in the.
Yeah, I just got that. Yeah, okay. So this is a line ALH4. Yeah, they're given RCOH. Reduction product is RCH2OH.
Yes, sir. Yeah, I saw that and I didn't see anything about last time. Okay.
Okay. Hmm. They are saying that the product which I mentioned is going to be forming, but you're still going to be having the product being formed. The reduction happening is what they are saying.
Yeah.
But you're going to be having a reasonable amount getting wasted, is what they are saying. This is feasible, but my gut feeling tells me it is not just that the product formed is going to be, what to say, good amount of wastage of lithium aluminum hydride is involved. But more than that, I think it doesn't give you a good yield also, because a reasonable amount of the carboxylic acid might end up forming RCO minus, or it'll
Yeah, it says
more or less
1/4
exist
of
as
it.
RCO minus only. So if it exists as RCO minus is quite difficult to basically, what to say, hit with a nucleophile. So if I have to hit with something over here, that is going to be not that easy over here, mainly because this R group is also bulky, and the O minus here will be resonating with this particular double bond oil. It means both of these guys are having delta minus to a great extent. So they will also be fairly bulky groups technically, because lone pairs will be like hanging around nicely. So पता नहीं इसमें I'm not 100% sure this will work nicely, but the next point is very meaningful. That acids are better converted to their esters before reduction with LiLH4. Yes, certainly. If you convert them to the ester, it will do a very good job. Very good reduction. Hoga. So
So
ester
can
might
you repeat?
definitely do a very good reduction. So the carboxylic acid should end here is what my gut feeling tells me. I will confirm. I will confirm if it is exactly that point over there which they are mentioning. 1/4 of the valuable reagent is lost in the formation. Is it only that which matters, or is it what I'm thinking which happens, which is that the rate of the reaction itself is going to be decreasing and it will not do a good reaction? So I'll
Okay.
confirm that thing, but theek hai, I'll check it out.
Yeah. Sir, like
Yeah.
in esterification,
Mm.
no, not esterification.
Mm.
Just
So what is the specific reaction we are considering now?
1 minute.
I start the recording already?
Yes, sir, you did. Yeah.
I did. Okay, cool. Yeah, I've sent you the last 3 classes of notes also. Good. I've been forgetting
Yes, sir.
that for a while, and let's get to the question. Okay, I've sent me a couple of questions.
So
Yes.
here, like when we do the reaction, right? First, this like
62
we'll take
AR,
the
which one are you talking about now?
like the you'll have to do the reaction in order to get both the answers.
No,
Right?
no, no. I don't. Oh, both are actually the same thing. 62A is the question. Okay.
Yeah, yeah.
Okay,
Yes.
okay, all right, let me have a look at it.
Hmm.
So you're going to be having this reaction here. We are doing Wilkinson's catalyst over here, and then we are going to be doing hydrolysis followed by methanol or water. What is that? Methanol or water? What are we doing hydrolysis with? Okay, chalo. Okay. And they're telling us it gets two products, B and C, where C is going to be containing no nitrogen. Okay, all right, okay, all right. So in this here, the Wilkinson's catalyst over here is going to be only reducing the alkene to alkane. All
So,
right.
but then
Hmm.
in our notes, it was given that only terminal double bond gets reduced. Is that correct? Or?
Honestly, I have no idea. Da.
Okay. I just went along
My
with
gut
the
feeling tells me though that what to say, you're going to be having in this particular case here, the double bond should get reduced.
yeah.
Why should the double bond get reduced over here? Because the benzene rings double bonds and the C double bond are much more difficult to reduce. So instead of reducing those guys, this fellow getting reduced is a little bit more of a bearable type of situation, I would say. Now,
There's a part.
in this here, the advantage of what you have at this stage right now is that they're not really what to say. Okay, let's have a look at the overall thing here. So when you do perform the hydrolysis over there, you're going to be having things breaking down over there, correct? So the part which is breaking down, which is going to be containing no nitrogen, is going to be your option C, compound C, right? So compound C over here, you're going to be having as the only thing which is going to be directly determining your Wilkinson's catalyst reaction. So
Yeah.
product C here for the above reaction, is it going to be, what is the answer option given there for product C?
B, sir.
Delhi.
B. Bombay.
Bombay or
Bombay.
Delhi?
Bombay, sir.
Bombay. Bombay.
So the thing
Yeah,
does
Bombay
reduce
is
the,
correct. Yeah, Bombay will be correct. Yeah, Bombay is the correct
like
answer
it,
there. Yes, tell me.
there is a possibility that this Wilkinson catalyst does not even reduce the thing, right? Like we should just
See,
ignore that.
sincerely speaking, I have no idea about what to say, how exactly Wilkinson's catalyst is going to be exactly operating. Now, in
Okay.
reality, though, it is expected to operate in the sense that it is going to be attacking the less, what to say, populated region, the one which is going to be more freely available. It will go attack. But when there are no regions available, what is there to say that it will not attack what is available?
Yeah.
Right. See,
Yeah.
effectively, what we know is that it attacks the least sterically hindered location or the corner wala fellow as much as it can. Right.
Yeah.
In this case, there is nothing else available. Now, there are other things available tantalizingly, but it cannot eat it. Right. There is
Hmm.
benzene. It's like you're
Yes,
a
sir.
beggar outside a five-star hotel.
Yeah.
So even something which did not originally look attractive to you starts looking attractive.
Hmm.
No, anyway,
Yeah.
coming back to the point here. So esterification here is going to be something which is like this. Okay. Now, in this here, the Wilkinson's catalyst there, realistically, I will let it stay as that I am not exactly 100% sure what is the way in which it attacks. It doesn't make a difference. I don't need to know. Neither do you. Now, next up,
So
what
no,
else
in
is
this
the doubt?
question I did that.
Only this was a doubt?
No, sir. That's one of my.
No,
So
in this here,
there's
this
one.
was a doubt.
Yeah. No, there's one more. So like this reaction, like A product will be the same thing without the double one, right? So the basically an ester. I mean, yeah,
A
ester.
product is going to be the ester without the
Ester,
double
right?
bond on the C double bond C. That's all.
Yes. Yeah. Now when we're doing hydrolysis of an ester, right? Why is it that like we get an carbo, sorry, anion, right? Like why does it have to stay on the like?
This is your ester.
Yes, sir. Yeah.
Okay, now tell me for this ester, what is going to be the thing which you're talking about over here?
So now like NaOH, it's basic medium. So OH minus would come and attack the carbon. Bond goes up, comes back down again.
Right, this is what you get.
Yeah, and then the
Then what
bond
happens?
comes back down, and then OR dash leaves.
Right.
Yes, sir. Yeah.
Effectively, that's what's supposed to happen. This is also going to
Yeah.
be reversible effectively, giving you R, C, double bond O, OH.
Hmm.
Now, in this here, this will of course not stay exactly as it is as well, because this is going to be with R dash O minus technically. You can put it like this. Is this the correct mechanism though?
That's what you're given.
No, this is actually not the correct mechanism. The actual correct mechanism goes like this. You're going to be having RC OH, you get an O minus, and you have got your OR dash. Okay.
Yeah.
Next step, what will be happening is an intramolecular acid base.
Between the hydrogen.
So we'll end up having this O minus and this OH over here. They will effectively end up, accepting H plus. That is, this H plus can basically go to this O minus, or this can technically react with water molecule and accept a H plus from there. Wherein it will end up becoming something like this.
But
Okay.
that's not stable.
Now you will end up having the elimination happen.
Oh.
Now, there are many different ways of playing this out over here. You can effectively end up, doing it in this fashion, or you can also say something like this will happen. All of these will be reversible effectively. So because they are all reversible, none of them really matter. You can say this fellow shifts inward, this guy gets out. So you get this.
Yeah,
Then
same thing as before.
at the time that this guy is leaving, this RO minus comes and attacks this. This will effectively result in another RCO minus now. plus an R dash OH.
Okay, so that's more stable. The
Effectively, it's all hogwash, sincerely speaking. Now, why am I saying it doesn't really make a difference? Simply because everything is in equilibrium.
sir, but
What do I
then the
mean by that?
options.
No, what does it?
Uh,
See, think for a second. Stop
yeah.
thinking about answering questions now.
Hmm.
Okay, stop thinking about answering questions for a couple of minutes. Answering questions comes as a supplement to understanding what's happening. Why am I saying none of this matters? Simply because all of this is in equilibrium.
Yeah.
So what is it that we observe? We observe all of these species as it is. I see RCO minus, I see RCO, whatever that RCOH, OH, OR dash, a little bit of that is there. I will also be seeing R dash OH. I will also be seeing a reasonable amount of the RCOH
Initial.
and R dash O minus also. I will have
Hmm.
all of them present at the same time. Depending on how much of each of them is present, then only we can basically start coming up with theories as to what all are happening. Now, why am I saying
Hmm.
all of this is possible to happen? And I don't really care? Simply because it doesn't make a difference, internally speaking. You're going to be having all of these various equilibriums playing out over there. Now,
Hmm.
depending on how you write the setup of the equation, you'll have different equilibrium constants at play though. I don't think I made sense to you yet, but it is okay if I did not make sense also. But just I understand this at this stage over here. You don't need to worry about what are the internal steps which are going to be happening. All you need to
Hmm.
understand here is that you're going to be having a nucleophilic addition type of attack happening from OH minus and some
Hmm.
sort of nucleophilic elimination happening where the R dash O minus is leaving. As simple as that. Giving
Okay.
you this as a product, more or less.
Hmm.
Now, the next game over here is going to be what you are about to ask me. What were you about to ask me?
I was about like uh, my main question was why does this carbo what do you call this COO minus stay as an anion and the OH becomes an alcohol or R dash O minus.
Because you're going, oh, that last step is the real question for you. Huh?
Yeah, everything else
The
fine, sir.
last step is the real question. Okay, all
Yeah,
right. So the
but
last
I
step
think it's
here,
huh,
what is happening is a simple acid-base reaction here. The R dash O minus, which is present over here, is a stronger base
the
compared to the
stronger. Okay,
RCO
that's right.
minus. And the
Hmm.
RCOH is a stronger acid than the R dash OH. So it will happen in forward
Forward
direction, this
reaction.
reaction more.
Exactly. Okay.
Obviously, it will end up giving you this as the product here, RCO minus and R dash OH. Right.
Hmm. Yeah.
Fair.
Okay. Yeah, that's right. Okay, sir. Hmm.
Next up.
Isn't it?
There is one critical point which you should understand though. Esterification reaction does not happen in basic medium. It only happens in acidic medium. All right, ester hydrolysis
Ah,
happen in both basic and
both
acidic,
yes.
but esterification only happens in acidic. It does not happen in basic. They will use that to play around in exams usually. Watch out for that.
Okay. Mm.
Okay, so we're going
Okay.
to be having some fellow PCC, something. Okay, all right, okay. So now this is a question which goes like this. Pay attention here.
Yeah.
So we are having this compound available right now. Now, this compound here, when I'm hitting it with PCC, what will you be getting? We'll be getting the two locations here. What is PCC going to be doing? It converts aldehydes. I mean, it converts alcohols to aldehydes and
Alcohol,
ketones.
aldehydes and ketones.
So you end up getting this.
Yeah.
Now, this is my compound A. Now, this compound A is going to be treated with this fellow.
Yeah.
Now, ethylene glycol, when it is going to be in the presence of H plus, what is this particular thing going to be doing? This is going to be effectively doing nothing but acetal formation. All right. So this is going to be doing Have you already done the reaction of aldehydes and alcohols?
Aldehydes and alcohols.
No. Okay, so let me discuss that.
Don't think so. Aldehydes and alcohols. Oh, yeah, I had a doubt on that as well. Yeah.
So let's quickly discuss this. If I'm going to be having, say, a particular compound, like say an aldehyde here, all right, I'm going to be reacting it with, say, methanol. What is going to be happening is, in this particular case here, this fellow will end up performing a regular nucleophilic addition reaction. Okay, wherein you're getting product obtained now as R, C, you will get an OH over here, and then OCH3 over here, and a hydrogen here like this. Okay, after 2 steps. It is not 1 step. I'm just combining it and putting it as 1 step because I am lazy. Okay, no other reason. I have no other reason for it. I'm just lazy about it. It's going to be 2 steps actually. First step is going to be O minus, and then the CH3OH will lose the H plus. Acid base reaction again. You notice acid base reaction is also going to be completely reversible.
Equilibrium.
So reversible steps, you'll be getting this. So 2 steps, both reversible. Okay, you get this. This compound is called as the hemiacetal. Now, this is very, very much unstable. It easily goes back to give you the aldehyde or ketone if you simply add excess water. Already add excess water, it will end up going back to hydrolysis, it will go back to the aldehyde or ketone. Now, this is going to be happening in the presence of H plus, usually dry, not in the presence of water. Because if I said, as I said just now a while back, you add water, what will it do? It will do the backward direction. It goes straight away in the backward direction. So you need to have it in the forward direction here. So you keep it in the forward direction idea here. So dry H plus will push it in the forward direction. Next up, if you end up doing some more CH3OH in the presence of more dry HCl, what happens in that particular case is even that OH which is present there will basically end up leaving. Again, this will be reversible 2 steps. And the product obtained will be this. This product is called acetal. Okay. Now, the interesting thing here is this. Acetal is a little bit more stable than hemiacetal. All right. So stability-wise, in some cases, acetal is a little bit more stable. All right. So acetal usually, acetal also undergoes hydrolysis very easily, by the way. All right. But acetal is little bit more stable. I should not put to slightly more stable than hemiacetal. Now, this slightly greater stability than hemiacetal is especially true in basic medium. So in basic medium, this is going to be one of the key advantages for things over here. Now, why is this a useful technique to basically have? Well, it goes like this. If I have, say, molecule, like say this. All right, this is an aldehyde ending. This is a keto ending.
Yeah.
Okay. What I'm going to be doing is I'm going to be reacting this fellow with ethylene glycol in the presence of dry HCl gas. What happens in this particular case is exactly what I just talked about a while back. You're going to be having, in this particular case here, what is the first step which I just showed you over here? This first step here, nucleophilic addition.
Yeah.
So this nucleophilic addition which is going to be happening is going to be having steric hindrance as the main factor, right?
Delta
The
plus.
factors which is involved over there. So
Hmm.
you're going to be having in this molecule here, if you're considering, this is one location, this is another location to be attacked, correct? So this location, this location is an aldehyde. So which location is offering more steric hindrance here?
Ketone.
Ketone. So this fellow will attack which one, aldehyde or ketone?
Aldehyde.
Aldehyde. So what happens now is we'll end up having this fellow going and attacking the aldehyde not once but twice to form the acetal in this case. First it will form the hemiacetal, then it will form the acetal.
So two more.
Because there are two OH groups in the same molecule here, correct?
OH groups, yeah.
So it will first form the hemiacetal and then it will form the acetal. So what will be the hemiacetal first? I'll show you the hemiacetal here and then I'll show you the acetal as well.
Sir, if the instead of a carbon to the ketone, if there's some like electron withdrawing group, then where would it go?
Think. It'll go there, right?
But like, what if it was like NO2?
What type of electron withdrawing group can you put over here? This is your location to put it, correct?
Yeah.
Can I put a chlorine here? If so, what group is it then?
Acid.
Halide.
Acid halide, yeah. Exactly.
So you can, but you'll have to basically understand it changes the property itself completely.
Okay. So, okay, fine.
Okay, now in this particular case, you'll be getting product first obtained being like this.
Oh, not yet. Yeah.
Okay, you first get this hemiacetal. Next one, what will happen is you'll end up having this disappearing and you'll have this also disappearing to an extent. So let me redraw this part now. I'll be having something like this. This will be the product formed over here. This will be the acetal which is going to be formed after this step here. You understand the idea here?
Yes.
Now, this fellow here, if I react it with say LiAlH4, what will I be getting as the product now? I'll be having this location undergoing reduction.
OH become, yeah.
Right. So I'll be getting product obtained as carbon, carbon, OH, carbon, carbon, and this fellow will be intact as it is. Now, if I perform, say, hydrolysis, LiLH4 is generally done in basic medium, right? So the acetal is going to be stable in basic medium. So it doesn't react with the LiLH4 part there. Now, when we perform hydrolysis, H3O+, what is going to be happening is we'll be getting product obtained like this. And 1, 2, and 3. The aldehyde group basically got protected in the entire process. So if you look at it from the starting here, from here to here, what did we do? We selectively reduced only the keto group. Selectively, we reduced the keto group while we protected this aldehyde group completely.
Okay.
So this is acetal, this thingy is basically a method to protect the aldehyde group usually.
Okay.
You understand the idea over here?
Yes, sir.
So let me put it down over here. So the aldehyde is protected.
So this is when only when reaction with ethylene glycol, or like
only
when it reacts with ethylene glycol, or like similar things. Like,
sorry, repeat again.
Is this the does the aldehyde get retained only when it reacts with ethylene glycol? Is it like a property of ethylene glycol, or like do other?
No, it is not just ethylene glycol. It is any geminal, diol, thiol, dithiol, those kinds of things. So it can be a
Okay.
dithiol also.
Hmm.
Anything which can basically form this kind of capping. So you can think of this
Hmm.
as capping. Another name which you'll be using or which you'll come across in chemistry nomenclature for this or associating with this is called capping.
Hmm. So this is similar to the ozonolysis one, right? Does that have anything to do with the, like
No,
ozonoid,
you're thinking it is
ozonation?
similar because they both look like houses. That's all.
Exactly. But
No,
like, okay,
no.
okay,
That house is not a single story house. Like this one is a single story house. It's a double story house.
2, 3
See,
was.
it's not that. There's like two separate shapes there. There's a middle
That's
bond
true.
there between them.
Ah, yeah, that's true.
We're
Yeah,
not going to
CC
go now. We're
bonds.
not going to go anywhere now. No. I'm not going
Okay.
to go back again here. Now, in this case here, this is going to be the idea over here for now. Now, anything else you have to go back to over here. So in the question which
No.
we were talking about over there, what is going to be happening here? What will happen here?
Aldehyde retained. The other thing is
Aldehyde gets
ozonolates.
protected,
Yeah,
right? So the aldehyde will get protected here through the process, and we'll be doing some steps on the other fellow.
that
So what
gate
are these
becomes.
steps being performed on other fellow? Grignard reagent is the attack over there. You understand what's happening now?
1 second, just.
So we're going to be
CH3.
protecting it. So in this process here, we'll be getting product obtained as, let's say, so we'll have protection done here. So we'll have this, and this fellow in the next step is reacting with Grignard reagent. Okay, so this is compound B. This compound B is reacting with Grignard. CH3 MgBr. Now CH3 MgBr, the Grignard will of course solely go and attack this carbon here, no other location. So the product it will be producing now will look like this.
So why won't that ketone turn into a alcohol as we did before?
Mhm.
Wait, sir, could you go back to the reaction you wrote just now?
Mhm.
Stuck. Okay, nothing.
Acetal, the advantage is it is stable in basic medium.
Yes, sir.
And most of your LiLH4 Grignard reagent reactions are done in basic medium. Oh,
Yeah.
for a second, it is raining. Give me a second. I have to go. Yeah, sorry, dude. There were clothes hanging outside. Yeah, where was I? Can you hear me, dude?
Yes, sir, yes.
So do you want me to continue on with the question or you already solved off with the question?
Oh, yes, sir, I'm fine with the question now. Yeah.
You done with the question?
Just give me a minute. One second.
So in this here, the Grignard will basically end up attacking here, while this location is fully protected. Yes, huh?
Why are you keeping that? Okay, because we didn't react with LiLH4, you're keeping that structure as it is. That
Yes.
penta.
LLH4 ke saath, that
Okay.
flow will not react. It is stable.
Okay, I was thinking that. Okay, my bad.
And in the next step, in the hydrolysis step there, we will have the entire thing going back to normal. Meaning we'll have, see, the hydrolysis is the second step from B to C. Pay attention to that.
Hydrolysis, second step. Yeah.
So you'll get back the aldehyde there and then sodium borohydride, NaBH4 and ethanol. So now when you do NaBH4, NaBH4 will clinically go attack only this location here and not anything else. So you'll be getting final product obtained here like this, where you'll have an OH and a carbon here, and the neighboring fellow will have a carbon and then OH like this. And this hydrogen will be from NaBH4.
Sir,
It's going to be the same.
so it's not the NABH which is turning that cyclic thing into aldehyde.
It's not the NABH4 which is turning the cyclic thing into.
Aldehyde.
Of course not. It is a
Okay.
hydrolysis.
Okay, understand.
This is the one.
Okay, sir. Yeah, got it.
See, this is the one which has converted this guy here.
Yeah, got it. Yeah.
Okay, next up. How is your inorganic preparation coming along? Any doubts in inorganic?
Not really, sir. No.
Any theoretical questions which you have come across which have not worked out properly in inorganic?
Sir, nothing as such, sir. Like no, sir. Yeah, there's nothing.
Inorganic is going quite smoothly.
Yeah, as of now. Sir, for questions, would you recommend I just do the PYQs or the VKJs for them? For questions, inorganic.
Huh? Why would you want to
VK
solve questions in inorganic, man?
Okay. No.
Sincerely, I'm asking. I mean, realistically, give me a second. Just get the trouble. See, what level of questions are you looking to solve in inorganic? That's the question. What level do you want right now? Are you aiming for JEE advanced level or JEE mains level first?
Mains first.
Yep. Then why the fuck do you need to solve questions at this stage for inorganic?
Okay.
Yeah, right.
Yes, sir. So then for advanced, what do I have to do then?
Advanced ke liye you will have to practice, right? Advanced ke liye, the practice is going to be old JEE advanced questions mainly. And of course, you'll have to practice what to say a little bit more than that, certainly. Initial thing is going to be old JEE advanced questions because not the single option correct type, the more interesting ones which show up, which are comprehension based, which are like what to say A giving B, giving C, giving D, giving E, giving F, giving that type of nonsense. So when it comes to JEE questions, they are definitely a cut above. You need practice in inorganic as well. But JEE mains level, no. You especially do not require much practice. If you sit and get your theory done properly, thoroughly, you'll be clear, good to go, so to say.